on 2.3, number 14. And this one's a little tricky keeping track of the units on it, so I'm going to try to be real careful on this and do this correctly. So, F of V is the gas consumption in liters per kilometer. So the units on this are liters per kilometer. And velocity is in units kilometers per hour. In other words, this tells you how many liters of gas it uses to go 1 kilometer if it is traveling at V kilometers per hour. In addition, suppose that F of 80, so I'm going 80, the number of liters you use per kilometer is going to be 0.05, which is 1/20th, 5/100 or 1/20th liter per kilometer. And F prime of 80, this is the rate of change, so it's going to change. This number is 4/10 hundredths thousand, 4/10,000ths, which is 1/2500th. You change that to a fraction, and I prefer it. And it'll be the change in F, so that'd be liters per kilometer per the velocity, the change in y, and the y is the liters per kilometer. The change in the variable 80, that's in kilometers per hour. And if you invert and multiply, you get this strange unit of the hours would be times the numerator, so we got liter hours per kilometer squared. Probably better to leave it this way, but that's what it is. Okay, got that information down. Now, A, suppose G of V is the gas consumption in liters per kilometer. Oh, no, excuse me. G of V is the same car that goes 1 liter on a gas at velocity V. What is the relationship between the distance it goes per liter? So that's kilometers per liter. That's the reciprocal of this. So G of V is 1 over F of V, because its units are kilometers per liter. Just the reciprocal of F of V. Okay? What is the relationship between their reciprocals? Now it says find G of 80. So G of 80 is just simply going to be the reciprocal of F of 80, and that's 1/20, so this could be 20 kilometers per liter. That one's easy. But G prime of V, we have a quotient here. So we have to take the derivative. So the derivative of 1 is 0 times the denominator minus the derivative of the denominator times the numerator over the denominator quantity squared. So G prime of 80, this is 0. We get negative F prime of V. F prime of V is this, so we get negative 1 over 2500, and the units on this is, let's see, the derivative of that units on f prime of v. F prime of v. See, f prime of v were um, liters, hours over kilometers squared divided by f of v squared. F of v is 1/20th, and that's got to be squared, and so do the units. So that's liters squared per kilometers squared. So this works out to be so we got 1 divided by 2,500, and that should be negative, times -1. Forgot to put the negative on, so there's that correct. Divided by 1/20th. Let's see, 1 divided by 20, quantity squared, which is, this comes out to be negative 0.16. And what are the units? Well, these will cancel if you invert and multiply. And we'll have liters over liters squared, so one of the liters will cancel, and we'll have hours per liter. So this will tell us how many hours more we can go per liter. Okay, that's A. B. See, that's on another page here. Okay, do we have it there? There we go. Okay, B. Let H of V be the gas consumption in liters per hour of a car going velocity V. So this is going to have the units of liters per hour. While we have liters per kilometer as F of V, if we multiply it by V, we'd have liters per kilometers times kilometers per hour, and the kilometers would cancel, and we'd have liters per hour. So H of V must be F of V times V. And they're saying it tells you how many liters of gas a car uses in 1 hour. Liters per hour, going at velocity v. What is the algebraic relationship between these? Now find H of 80, which is going to be F of 80 times V, which is 80, and the units will be, the F of 80 is 1/20th liter per kilometer times 80, which is in times 80 kilometers per hour. Kilometers cancel, and we get 80 divided by 20, which is 4 liters per hour. So you're going to burn up 4 liters every hour of driving. Now to find, they wanted us to find H prime at 80. Well, let's just write H prime of V first. So H prime is going to be, since we've got a product, it's going to be F prime V times V, derivative of the first times the second, plus the derivative of the second. Derivative of just V is 1 times the first. Okay? So we have f prime of v, which is 1/2500th strange units, liters hours per kilometers square, times v, which is 80 kilometers per hour, plus 1, no units on the number 1, times f of v, which is 1/20th liter per kilometer. So we get the units. Let's check here. We get kilometer canceling one of the kilometers, hours canceling hours, and we get liters per kilometer, liters per kilometer. Both of them come out liters per kilometer. So we get the number to be 80 divided by 2500 plus 1 divided by 20. And we get 0.082 liters per kilometer. And another way to look at that is that liters per kilometer per kilometers per hour, and it becomes liters per kilometer. Okay. And I think I've explained how these pertain to these. This is saying that for every kilometer faster you go, the amount of hours you can, H of V is liters per hour you're burning, and so you're going to be burning 0.82 more liters per kilometer for every V faster you're going. Yeah. Okay.